Hello everyone, welcome to workshop 106. Today we're going to be looking at understanding internet infrastructure, an overview of terminology and technology and terminology. This is normally a workshop that is had at the very beginning of the Internet Governance Forum. So this year it's a little different, but we will be walking through the 101 explanations or basic explanations of internet technology and the terms that you would hear throughout this forum. I have with me a very knowledgeable panel. I am Bevel Wooding. I am an internet strategist with Packet Clearinghouse, a nonprofit organization. I'm also the program director for the Caribbean ICT Roadshow, an initiative designed to do something very similar to this workshop, help people understand how the internet works. I have with me Bill Woodcock. He is the executive director of Packet Clearinghouse, previously operated internet backbone networks in the United States, Europe, and around the world. Hisham Ibrahim, IPv6 program manager at Afrinic and past manager of the Egyptian Ministry of Communication. And then we have Jane Coffin, development strategist at ISOC, previously National Telecom and Information Administration and USAID. So a very knowledgeable group here to help guide you through today's session. By way of introduction, I want to just give you some of the very basic terms that we'll be looking at. And first is, what is the internet? Of course, this is the Internet Governance Forum. We're hearing a lot about what's happening on the internet, but I think it's important for us to start with just an overview of the internet. Most people think of the internet in terms of the cloud, some place or mysterious space online where stuff happens. In fact, the internet is made up of several networks. That's why it's called the internet. It's an interconnection of networks. And those networks exist in this virtual online space, and they connect various servers together, and these servers run services. So if we had to have a definition of the internet, it would be the internet is, and you can see it on the slides, the internet is the network of networks. And you see here a difference between the internet with a capital I, that's the real internet, the proper noun, where it provides global end-to-end internet protocol connectivity between these servers or these computers. And then there is a lowercase internet, or any set of interconnected networks. So when we are referring to the internet, what we're referring to is the capital I internet, that is global end-to-end protocol connectivity using TCP/IP protocols to route traffic between servers online. And what we will be discussing today is how does the internet work, and the panelists one by one will be carrying you through an explanation of the technical topography of it, and they will also be discussing in some detail the terminology that you'd normally hear associated with the internet. Now, this is intended to be a very interactive session, so you are free to indicate if you have questions. If you don't understand something, we can go over it again. This session really is designed to allow you to have a really comprehensive understanding of some of the terms and the systems that people take for granted when they discuss the internet and internet governance. So I'll turn you over to Hisham first, and he will describe resolving domain names and basic internet functionality for you. Hisham.
Thank you very much. So, in order for you to get better understanding, please look at the screens, because you will see a lot of graphs that will help with the terminologies and topologies that we're discussing. So, to start off, let me read the slide first. Resolving the domain name to an internet address. Just like the user of the 20th century telephone needed to look up the name of a person they wanted to call on a telephone book to find their telephone number, to dial to complete the call, our computer needs to resolve the domain name found in the URL to a numeric internet protocol address in order to address the packet which will contain the query of the web page. that's a lot of jargon. That's a lot of words that you'd hear at meetings like these, and this is exactly what we're trying to actually discuss. So we're trying to go over what these are. So the first thing is what's an IP address, or what's an Internet Protocol number. So an IP address is actually what the computer uses to identify a destination on the internet. So what happens is machines understand numbers while human beings understand names, right? So when a machine wants to locate or find a website or locate a certain destination, it has an address. Think of it this way: when you're sending a message, when you're sending a mail, you write your address, your home address, and you write the destination address, right? And the postal service takes those addresses, understands those addresses, and delivers it to its destination, right? That's exactly how it is. And if you do not put the sender's address, it will not be able to return the mail to you back. That's exactly what an IP address is on the internet. Okay, it's just the addresses for people to be able to locate where the traffic is going back and forth. And you'll hear stuff like these IP addresses have to be unique, because if you write an address that is duplicated, the postal service will not be able to deliver it. And in this case, the postal service is the internet. Yes, next slide, please. So yes, so how these IP addresses are managed. You probably heard during these meetings something called the IANA function, or the Internet Assigned Number Authority, which, think of it as the reservoir of all the unallocated and unassigned IP addresses, right? The IANA function would, after that, under it would be, please next slide. Yes, there will be 5 regional internet registries under it. So what a regional internet registry does is it takes that space, and each one is dedicated to one particular region of the world. So you'd find Afrinet, which is in charge of that space in the African region. You'd find Epinet, which is in charge of the Asia-Pacific region, AREN, North America, LACNIC, Latin America and Caribbean, and the RIPE NCC, which is which deals with Europe, Middle East, and Russia. So based on your geographical location, you would belong to one of those RIRs. And these RIRs take that space afterwards and give it to ISPs, the internet service providers, and sites like big organizations and big companies there. So you as an end user at your home or at your company, you probably get your connection. I'll walk you back the other way around. So you get your connection from an ISP, and you get those IP addresses from him. When he needs IP addresses, he goes to his registry, and so on and so forth. You may have heard about Ipv4 depletion, which actually means at the IANA level, at the top reservoir, they ran out of IP addresses, Ipv4 addresses. Yeah, no, that's fine. That's fine. Yeah. And 2 of the 5 regional internet registries have also reached /8. So the final block of /8 is 16 million IP addresses, and that's the final block. So this is some of the terminology that you may have been hearing during the meeting as well. Moving on. So, yeah, and until we get the slides. So the packet, yes, so the packet would be, in the example I gave, would be the envelope. The envelope that carries the information that you want. And we already discussed what the address is, which is the IP address. Also, one of the words that was in the text was resolve. What resolve basically is it's the process of converting the human words that we know into the numbers. So when you type in www.isoc.org, for example, you know ISOC, you know the name, right? That has an IP address equivalent to it. And what happens is that gets resolved. What you just typed in, and we're going to see how, gets resolved into the equivalent number. Or if you type a number, it gets resolved to the name. So that's what the word resolve means. Query is basically a message that usually originates with the human request, like when you say, give me your web page. And usually a lot of information comes after that. So if you go to the next slide, please. Yes, packet we already discussed, which is the envelope that you send with the information back and forth. So when you type the example I was just giving, so when you type, and we all use the internet, we all use browsers, so we go to the browser, you type your URL, which is www.isoc.org, for example. And we all use URL, we all say URL, but a lot of people don't know what URL is. So URL is actually Uniform Resource Locator, and that's exactly what it is. Its function is to give the computer a clue on where to look for that web page or the service that you're looking for, whether it's www, whether it's mail, whether it's any kind of other service that you're trying to access over the internet. Next slide, please. Okay, so now we're examining the URL and what it actually contains. So the first part of the URL, when you look at it, you'd see something that says HTTP, which basically is Hypertext Transfer Protocol. Okay, and sometimes you'd see HTTPS, which is secure. Okay, these were protocols developed at the Ietf, which you will hear more about later on, which basically are the way that these pages get transferred over the internet. The second part of it would be, let me just put the slides in front of me, sorry. Yes. The second part of it would be the second level, which would be the name that identifies the organization or where you want to go. The third part of it would be the sorry.
Now we're up to the third part.
Yes, the third part of it would be the www, which is the World Wide Web. It could be something else. This is if you're actually going for a web page. It could be, for example, mail. It could be other services that you access over the internet. So sometimes you type mail.isoc.org, which depends on the service that you're trying to query. So yes, so top-level domains. You may have heard also talk about GTLDs, generic top-level domains, or you may have heard something called CCTLDs at some of the sessions that you attend. So the GTLD is actually the generic top-level domain, and there are a lot of examples of it, like .com, .net, .org. These are GTLDs, and now there is the process of trying to get more GTLDs out, like .africa, for example, or .amazon, and you hear a lot of these conversations during some of the workshops that you have. The CCTLDs are the country code top-level domains, so you get something like .uk or for United Kingdom, .za for South Africa, and so on and so forth. Yeah. Next one. IDNs. You would hear of IDNs, which are internationalized domain names. So far, all these URLs are written in Roman characters, right? But a lot of the people that access the internet do not necessarily know English to be able to write them. So what they did is the IDNs enable you to actually write these URLs in other scripts, in other languages, like in Arabic, for example, or in Hebrew, or in like Chinese. And that's what an IDN is. Next slide, please. Yes. So what happens when you type in that URL is basically your computer goes to your DNS resolver, and it asks them, well, how can I find www dots, whatever you're looking for, and that actually goes up and to the nearest root name server, and it asks that same question. How can I find? But remember how we segmented them into three parts. So it starts with the right-hand side, which is .org. How can I find .org in this example, or .com or .net? Okay. Once it finds, gets the reply about that from the DNS lookup, it goes to the public internet registry of .org, and it asks it afterwards, how can I find ISOC, the name that you're actually looking for? And it replies back with that. And then it goes to the part where you're asking for, how can I get the www part of ISOC? And what it gets at the end is the IP address. And then the computer actually has that IP address. Now it knows where the IP of the destination is trying to reach. And the communication now starts with the HTTP, and Bill will walk you through the rest.
So, yeah, there are questions here, and we'd like to be very interactive with questions. So, anybody has a question, raise your hand, and Bevel will come by with the mic.
Hi, Igor Ostrovsky. Just a quick question on the first part you just covered. When my computer asks for .org ISOC, does the computer actually carry the packets, or it just asks the name? So, for example, if let's say someone intercepts the transcript, does he only intercept the query about ISOC, or is actually the message, let's say, what I want to see on the within the ISOC web page also contained in that discussion between
You've
those
cleverly
servers?
anticipated the next slide. I said you've cleverly anticipated the next slide. So everything we've just talked about here with these red arrows are just queries and responses about the domain name. So so far, what we did is the little laptop there, which says our computer, is it wanted to know how to reach www.isoc.org. So it said, give me the IP address for www.isoc.org. That's the resolution, the query and the resolution. So the recursive resolver acted on our behalf, and it went to the root server, it went to the .org server, it went to the isoc.org server, and finally it got the www.isoc.org address. And then it gave us that address. The next thing that happens is, now that we have that IP address, we can go and send a packet to www.isoc.org web server and get a response back. So then the question is, how is it that that response, that query and that response get through the internet? And I'm going to talk a little bit about routing now, which is the process by which packets get through the internet, the process of deciding at every juncture what direction the packet will go. So kind of like you're driving down a freeway and you see an intersection. How do you know which turn to take? That's routing. So the topology of the internet looks something like this. This is a very boiled down version, but it's representative. We have one user here, but there are actually 2 billion more of them out on the internet. We have 2 internet service providers here, but there are about 8,000 more of those out on the internet. And we've got 2 exchange points, but there are about 350 more exchange points out in the internet. But what you see here is kind of the boiled down version, the simplified version, representative of the whole internet. So there are 2 ways that packets can be moved between parts of the internet. One way is called transit, and the other way is called peering. Transit is a service that you buy from someone where you hand them your data and some money, and now it's their responsibility to deliver the data to wherever it needs to go, okay? And the opposite is true as well. You're handing them money, and it's their responsibility to bring you data that's addressed to you, okay? So you give them money, and you make it their problem. The other way of moving packets is peering. Peering is when you have a relationship with another network where no money changes hands, and you can hand them a packet, and they can either deliver it or not. It's up to them. Or they hand you a packet, and you can deliver it, or you can throw it away. Doesn't matter, you know, you don't have a responsibility to them because they haven't paid you any money. So you might think, well, why would they send me a packet if I was just going to throw it away? And the answer is, they wouldn't. They would try very hard to not send you a packet that you were going to throw away. That means that they would only send you packets that you wanted, packets that somebody else had paid you to receive. So if you're an internet service provider and you're peering with other internet service providers, the only packets they hand you are ones for your customers, because your customers have already paid you to bring those packets to them. Okay? So peering is for no money, the handing back and forth of packets that are bound for your peers' customers. Transit is someone paying you to take a packet and deliver it for them. Transit is the relationship between a customer and a provider. Peering is the relationship between two counterparts, two internet service providers. So I'm going to now walk you through this diagram, and we'll see how a query gets from our user to our server and how the response gets back. So first, from the user to their internet service provider, the one that's shown in red here, the user sends the packet to them. This is a transit link. The user is paying the service provider for the transit service. Now, the red ISP, they have two different paths here to deliver the traffic to the server. So either they could go through what's labeled here as Internet Exchange Point West, or they could go through Internet Exchange Point East. You see how there are two different paths between the red ISP and the green ISP. So speed times distance equals cost, right? The faster you want to go or the further you want to go, the more expensive it's going to be. Kind of like putting gasoline in a car, right? If you want to go really fast, it'll take more gasoline. If you want to go really far, it'll take more gasoline. So we are always going to deliver the packet on the shortest path we can. So the west internet exchange point is closer in this diagram than the east one is. So we're always going to send the packet out to the closer internet exchange point. This is called hot potato routing, after the children's game where you throw a stone between children and you try never to get stuck with it. Somebody sends it to you, you always get rid of it as quickly as you can. Because holding a packet in your network costs you money. Every circuit you have, every router you have, every piece of equipment only has so much capacity. If you fill that capacity with data and your customers are sending you more and more, you have to get that out, deliver it, before you can bring more in. So just like Hisham's example of letters in a post office, if the post office filled up with letters and you couldn't get any postman in there to deliver them anymore, you'd have failed, right? So the Postal Service depends upon being able to get the letters out again in order to be able to take more in to keep functioning. So same thing in the internet. Hot potato means you get rid of packets as quickly as you can, and that's the most efficient way of delivering them. So what that means, though, is that the green internet service provider now receives the packet at Exchange Point West, which is further away from them. They have to bring that into their network over a longer circuit, and then they deliver it to their customer, and they get paid, okay? Because the relationship between the two ISPs was peering, but the relationship between the green ISP and their customer is a transit relationship, just like the relationship between the red ISP and their user. So because this was a query, it demands a response. The response is going to go back from the server to their internet service provider, who in turn is going to make exactly the same decision that the red internet service provider did. They're going to look at the two ways the packet could be delivered. They're going to say, I'm going to send it out the short way, never the long way. Then it's the red internet service provider's responsibility to bring the packet in over the long haul back into their network, and then they get to deliver it to their user and get paid. So this model, it's called hot potato routing in the internet, but telephony people refer to this as bill and keep. You bill your customer and you keep the money. You don't have to pay someone else. This is contrasted with the voice network. In the voice network, you bill your customer, but then you have to settle with the other service provider. It's not how the internet works. In the internet, you bill your customer and you keep the money. You have responsibility. In this diagram, the red internet service provider has responsibility for doing all the work on that side of the dotted line, and they get to keep all the money from that side of the dotted line. No money ever flows through an internet exchange point, because transit doesn't go through internet exchange points, only peering goes through internet exchange points, and no money is associated with the peering relationship, okay? So if you take this pair of internet exchange points and you draw a line through them, it's like the sort of the high water mark, right? No money ever flows across that. The money always stays on one side or the other side, and the work always stays on one side or the other side. There's no responsibility that flows across that line either. So for the green internet service provider, you know, their work is on their side of that line, and they keep the money from their customer. So now I'm going to hand it over to Jane, who is going to talk about the Internet governance organizations.
And if you look at this, go ahead, we have a question.
Yeah, question. No?
How can the ISP know which is the shorter way?
So the Internet service provider has two ways of knowing what's short. First of all, they've built this infrastructure. So it's like you ask someone who built the roads which road is shorter. They're going to know because they built it and they're paying for it and their costs associated with maintaining it. And so they know what's shorter or cheaper. But at a more technological level, parts of the network are composed of elements, routers and circuits, and each one of those in the routing table, the topology map that gets built up, each of those contributes what's called a hop, and in the map you can see how many hops there are on any given path. So if I were to log into one of my routers, if I were to pull up a window that lets me communicate with the brain of the router, I can ask it, how would you deliver a packet to this destination? And it will show me all of the different methods of delivering, all the different paths that I could take. Just like if you pull up Google Maps and you say, give me directions to this town, it will show you 3 different alternatives, and it'll tell you how long it would take to get to each alternative. And it would be able to show you what other towns it would route you through on each of those paths. It's exactly the same inside the routers. And another question?
Yeah, the question is, maybe you've heard about the proposals that being made by Ethno Association about the principle of sending network party pays, and if you could explain what would that mean, because I really do not really understand what's behind the proposal, and share your opinion on whether it's actually possible or not in view of the scheme of billing that you've explained that is active now in the internet.
Yeah.
Thank you.
Okay. So, and there'll be another question there. So this is actually a very topical question. She's asked about Ethno, which is a European association of big incumbent carriers. And they have made a proposal which would get rid of the scheme that the internet has used since its inception, right? 30 years. We've had 115% growth. That is, we've doubled in size every 10 months for 30 years using this economic scheme. So this kind of exponential growth is very largely dependent upon having very low friction. There's very low business overhead to doing this because you don't have to settle with other people to do business. You hand them the data and then it's their problem and you keep the money. And this makes things very simple and very easy to grow, and you don't have a lot of external dependencies. It works very well in a competitive marketplace where there are many players who don't want to have to interact with each other a lot. They just want to bill their customers and get on with business. It works very well in a lightly regulated environment, an environment where everyone is responsible for doing the right thing themselves. Of course, they're responsible for following the laws, but their primary way of making money is to do business with their customers, not to lobby government to force someone else to pay them a settlement. Okay? The Ethno members, by and large, are large companies that came up before the internet and that are very heavily regulated. And for them, historically, the way they've made the most money is by sending lobbyists to government and getting government to change the rules under which they operate to force someone else to pay them money, someone who doesn't necessarily want to be their customer. So what they're trying to do is they're trying to get rid of the scheme under which the internet has had this exponential growth and replace it with one that looks more like the scheme under which the voice network had linear growth for the 100 years before that. So it is the opinion of almost everyone in the internet that this is a bad idea and that no one should be forced to do this. It is very, very unlikely that this proposal will gain any traction with anyone, but these things come up periodically and they have to be responded to, and I mostly view them as an opportunity for more people to be educated and more people to learn about the difference between the voice network, which does work that way, and the internet, which does not work that way, and why it is that the internet has grown so much more quickly than the voice network. So there's a guy here at the meeting named Sam Paltridge, who is the chief telecommunications economist at the OECD. So he's spent his whole career studying the differences between the economic model of the voice network and the economic model of the internet, and why the voice network is slow and expensive, and why the internet is fast and cheap. So if you want a slow, expensive internet, we can scrap the way it's worked and follow the Ethno proposal and make it slow and expensive. Or we can continue the way it has been and continue to double in size every 10.5 months. So we had a question there, and then we can follow on. Yeah, okay. Yeah. Good. You want? Yeah.
So thank you for your explanation. So that would basically mean that we would not have, well, let's say if the scheme is accepted, we would not have peering. It would be the transit between IXPs, and it's as I understood from your response, it's not possible to have like two models existing because it's just not competitive. Is
Well,
that right?
they're not compatible with each other. So you could have two models coexisting just as the voice network and the data network coexist right now. But fundamentally, the way the voice network works right now is it runs over the top of the internet, because even the voice network operators know that the cheapest way to deliver the packets is to turn them into internet packets and shove them over the internet and then pull them out on the other side and bill as though they hadn't done that, right? So, yeah, I mean, why don't you guys talk?
I did also want to just say that if you're producing content in a different part of the world, let's use Nigeria as an example. There's a novella culture growing in Nigeria where they're producing a lot of online content, which is being asked for by many other African countries. So Nigeria is no longer just a consumer, it's now a producer. So you've gone from a user of the internet to an active participant and content producer, which is exactly what you want in your economy. Content produces more exchange of business and other. So if I'm producing a show, online content, do I have to pay to send it now? Sending party network pays. My business model is not supported by this new proposal that's coming out of another part of the world. What will happen? Will I have a balkanization or will I have a separation of networks where where African countries say, well, why should we pay you to send our content to you when we're trying to produce it and make some money from our content? We want more content on the internet, and we want to see more diversity on the internet and more business and more interesting cultural content. If I want to see content from another part of the world, why should they have to pay me for me to see their content? So now it's a low-cost model when they're adding almost a barrier to for business in some ways, for small businesses, and now big business too.
I'll just like to add to that. So just to clarify, so there are two models of transit and peering do exist. So not everything on the internet is done through peering. Okay, just to clarify that. And peering, a lot of the agreements of peering just happen through a handshake. So, I mean, I meet up with Bill, we agree that we exchange traffic, and that's it, without, having to go through large documents and stuff. And as Bill was just explaining, the way that the packets get routed are through the shortest path. Okay, if something like Ethno passes, content providers will start looking into cheaper paths. That doesn't necessarily mean it is the shortest path. So you may end up in and when you look at it, you probably find more developed networks will be able to bill less for routing content through them, while developing networks will probably charge more because they're still building. So what you will end up in developing regions is your content will be going all the way, bouncing all over the world, not through the shortest path, but through the cheapest path, and that will directly impact you by getting more latency and becoming more expensive, like Bill was saying. So I just want to clarify that.
And just one of the other things to think about is if you try and retrofit a billing model that came up in the circuit switched environment to the packet switched environment, these are two fundamentally different things. It's like saying we have a billing model for airline travel, so now we're going to apply it to ice cream cones, right? You can imagine ways to do it, but suddenly you start running into problems when you go to actually do it. So I just went back to this slide for a minute, right? Here we had one transaction between the computer and the recursive resolver, another from the recursive resolver to the root name server, and then back to the recursive resolver, another from the recursive resolver to the isoc.org name server, and another back to there, another one to the .org name server and back again, and then back from the recursive resolver to your computer, right? So we have 2, 4, 6, 8 different transactions there. Who should pay? We have one customer here. In the current model, the customer pays to make this happen because they initiated the transaction, okay? In the Ethno proposal, the ISP would pay, in theory, the ISP should pay the customer, but I'm sure they've put a loophole in there to avoid that because the ISP in this case is them. The root name server operator should be paying them because the root name server operator is sending a response to the query, right? The .org operator should be paying the ISP because they also responded to a query. They didn't ask to be queried, right? They're just responding to it. But it's the responder, it's the one providing the data that would have to pay under this model. And then ISOC would have to pay once to answer the question, and then again because they send the web page, right? It's not really clear that this is an easy fit. So, yeah, sorry. So, another question. The mic's not on?
Is it on now?
Yeah.
Okay. I think we just jumped like 3 chapters forward, and just so so we're sort of back a little bit. I already forgot my question, but just that we're on this. In the current peer system, I understand that it's a sort of a bill and keep hot potato structure, but I understand that there are those who query and those who have content. I assume, therefore, that those who query are actually less burdensome on the network because their question is light, whereas those who have content and are sending content, their content is heavy. So I guess the conclusion is that it's cheap to ask, but expensive to respond. You could look at it that way. And hence, my question is, you said hops. So I understand that these exchange points, it doesn't work. It's not as easy as green and red. It's just not 2 exchange points. It's usually exchange to exchange points.
No, any one packet only goes through a single exchange point. So the model you saw there is complete in the sense that for any one transaction, any one query and response, it looks exactly like that. The rest of the internet, of course, spreads out around that, but is not involved in that transaction.
So I guess my question is, if the cost is actually bigger to deliver, then the bill and keep at the end of the day is unfair because, you know, I'm let's say I'm an ISP and I'm in a country that just likes to ask a lot of questions but doesn't have a lot of content. But I collect my fees, and then at the end of the day, those who host ISOC will actually need to cover the cost of delivering that. And so as a consequence, I'm just wondering if you're right that if there in a highly competitive market where there is an even amount of, let's say, questioners and responders, that probably equals out, but that's probably not the case in the real world. I'm sorry. Just to clarify, what I'm getting to is that we've heard Secretary General Touré of the ITU talking about the problem of third world countries that are paying for incoming spamming, and I guess what a lot of the ISPs in the African countries are saying is, fine, we'll be happy to deliver your spam to all our users, but you pay us and we don't pay you.
So just so that we're clear, in this model, you're positing that the red ISP and the user are in a developing country that is, say, underprivileged or where money is scarce, and that the green ISP and the content provider are in a developed country where money is plentiful. And so you're asking, wouldn't it be fair if, for some reason, the green side were to pay money across into the red side? Is that kind of the question?
Yes, although we could also switch it around and say that sometimes it may happen that the content is in a developing country. And it just either way you look at it, the real cost of trafficking, of routing, is not borne equally. That there may be asymmetries.
Well, by definition here, there's symmetry in the sense that half is carried by one and half is carried by the other. Now, let me address more specifically your question, what if the query is very small and the response is very large? Okay? The way that gets dealt with in the real world, the reason why people can afford to carry queries is because the response doesn't go very far on average, because the person providing the response, the person providing the data, the website, it's to their advantage to replicate that data and put it as near the person sending the query as possible. So to give you a real world example, let's say that we have somebody in Nairobi who wants to go to the Google website, okay? You're thinking, well, there's a lightweight query that's going to go all the way to the US and a heavyweight response that's going to come all the way back from the US, and somebody in Nairobi is going to wind up having to pay for the long in from the US for the big packet, whereas Google in the US is going to pay for the long in for the little bitty packet from Nairobi. Except that's not what actually happens. What actually happens is Google builds lots of infrastructure in Nairobi in order to serve the pages directly from Nairobi to people in Nairobi. So neither side pays very much, and it creates investment in Africa, infrastructural investment, jobs, and so forth, right? So content providers replicate their data to get it near the users so that the users will have a good experience, because the time it takes for the web page to load for the user will be much smaller if they push the data towards the user, in addition to it reducing costs for everyone. Because Google, of course, they have to multiply their costs by the billions of users that use them, so they're trying to minimize costs as well. Regardless of whether the inbound cost or outbound cost was higher, they don't care. They're just trying to reduce the costs overall. They don't want it to be expensive for people to reach them any more than they want to have to pay a lot to reach people.
I just wanted to comment on what you said, because a lot of the arguments in favor of the ethno would say, like you would say. So it would say, let's say I'm coming from a developing nation and our networks are still being built. So we're building the infrastructure, we're going to the rural areas, we're delivering all the way to the home, and then the content providers that are in developed nations just come into my home, they sell books, they sell services, they do all that, while my network is the one that's actually paying to delivering all that service. And the debate that they're going with for the ethno is saying, now I'll get a piece of that action, I'll get some money out of doing that. And as already Bill has mentioned, the process of, so we didn't just wake up one day and find this internet thing. All the stuff that Bill was going over is the things that came over time. So when the internet first started, it didn't have web pages on it. The www concept was not there. It was just, mail exchanges and stuff like that, because mail predates www. And then they invented the web pages. And then something happened. The video content started coming online, and YouTube and other content providers started doing that. And as Bill mentioned, so they started building cache servers that would cache that information and put it nearer and closer to you to enhance user experience instead of waiting the package to go all the way, of course making it cheaper and all that. And the concept of something called Cdns emerged as well, content delivery networks, that would do, so when you do your Apple apps, you buy your apps, or you do your Microsoft updates and stuff, all of that is delivered through something called the CDN that's all over the world, and you don't have to go all the way to Apple in the US to get that content. And all of these are concepts that developed with the internet and helped the exponential growth that we saw. So for us to scrub all that out and say, okay, now this wasn't done properly, and let's rebuild how this internet thing has grown. And just to mention something, the internet was has the highest growth technology in anything that you've seen. It took, and there are slides that were shown yesterday about how much time it took the refrigerator to go into homes, how much time it took the VCRs to be into homes, and how much time it took the internet and mobile devices to get on the internet. And you can see the rapid growth because of these technologies that we're talking about here. So to scrub all of that out and say, no, that wasn't really proper, let's go back to the telecom model, which by the way is dying, and now they're going to the internet model of putting packets and pushing it out all over, doesn't really sound that logical anymore, does it?
Let me give you a counterexample though. So let's take, I gave you the example of Nairobi, where everything works quite well, and half the participants in the exchange point in Nairobi are networks from overseas that are paying to be there, right? Let me give you a different example, which is Azerbaijan. Azerbaijan has no internet exchange at all. So let's say you're an internet service provider or a user in Azerbaijan. Normally, you would push traffic out on a short outbound path and pay to bring it in on a long inbound path. But if you're in Azerbaijan, there is no internet exchange here. So you're paying both long haul to get it to, say, Frankfurt, and long haul to get it back from Frankfurt. So you're paying a very large fee, both directions, long haul, whereas the Google server or whatever in Frankfurt is paying almost nothing, right? Because it's short both ways for them, okay? So how do we solve this problem? Build an exchange point in Azerbaijan, Google will build out here, Akamai will build out here, Limelight will build out here, so forth, right? So then you think, well, is it difficult to build an exchange point? Not so much. It's a few $1,000s. They typically pay for themselves within a few hours or a few days.
So anyone can build an exchange point?
Yes.
And become the 301 or 302nd and 3rd?
Yep.
And make a handshake deal and say, I now
Yep.
deliver you traffic, even though the handshake is going to result in probably one-way traffic, because as my exchange... Well,
No, it's
it will
all
always be
bidirectional. Yeah. So there's a new exchange point build about every 3 weeks. The Caribbean, there have been a bunch of new ones in the Caribbean over the last 6 months or a year. There are new ones popping up in Eastern Europe all the time. The area, we right now are sort of in the center of the area that lags most right now. So Central Asia and the Gulf, the Persian Gulf, are the region that is slowest right now to develop internet exchange points.
Okay. So I just want to give an example of why these exchange points are actually useful in a different sense. So when you're traveling, when you're flying, when you're taking a plane, okay. So my organization is based on a small island off the coast of Africa. Okay, but whenever I want to go to another destination in Africa, I have to fly through Dubai. Dubai built a big international hub that makes it more sense for airplanes to fly through it and dock through it, and it's much more efficient and cheaper for it to do that than to fly directly from the coast of Africa to another side. And the bigger that hub became, the more people came and started doing that. When I came over here, I flew through it. So even though I'm flying within Africa, I still left the continents and came back. Also for a long time before Dubai, and this is still the case, the Charles de Gaulle airport in France. So my mail, so first time I had something FedEx to me from Egypt, which is in Africa, to Mauritius, coast of Africa. They sent it to France, and then they sent it back. And for me, it didn't make any sense, but it does make sense financially, because the big hub, it would reach me faster and it would reach me cheaper. And that's what the exchange is all about.
The difference being that building a major international airport is $1 billion and 10 years payback, whereas an exchange point is, say, $5,000 or $10,000 and a day or two payback.
And one other thing about the exchange point, in Curaçao, one of the islands I think Bill's talking about with one of the most recent IXPs, I was there about a month ago. We were doing an IPv6 day or something like this with the Internet Society. It has lured in more business. The cable operators, Columbus Networks, one of the largest submarine cable operators in the Caribbean, is now coming in and is able to offer service. Without that exchange point, there's no reason for them to come and do business. So you're bringing in foreign investment. The other thing I want to just mention about this Etno proposal, there's an assumption that the traffic models are going to stay the same. There's a cable being built from Brazil over to Africa. So what will happen when that cable is lit? Lit meaning active, and the traffic going back and forth with Brazil. So do you think the traffic is now going to still go up through Europe? No. If I'm going to send traffic over to, I might send it through Brazil now. So you can, technologically, that can happen. So the thing is, making decisions based on what you think the old telecom bilateral relationships sort of might do if you impose it on top of the internet was not designed that way. So if you impose that structure on top and you think you're going to make the same type of return, you could actually kill the investment coming into your country. As Bill has said, there is a cache network, a Google cache, being built in Kenya. There's one in Nairobi right now. The content network there is attracting other investment and bringing in human capacity development. It's this interesting ecosystem of economic growth, human capacity development. You have a stronger IT culture in your country when you have that being attracted. Everyone thinks, oh, Africa, you're like, there's so much going on the continent right now, and in Latin America and other regions of the world. You've seen it in Eastern Europe as well. It's a fact. You know, it's not as if we're making it up. So you've seen the growth, you've seen the infrastructure being developed, you've seen your own cultures having a stronger IT culture, which is tech culture, which is actually a good thing if you're trying to build up your infrastructure.
I'll just comment real quick before I give Jane again to finish her slides. So what an IXP actually provides in a country, it gives better user experience, because latency becomes less. Okay, the money stays within the country, because one of the models that one of the sayings that people usually say about IXPs is keeping local content local. When you are on one ISP in a country and you want to get information from another, it doesn't have to leave your country. It could stay within your country, and instead of paying that money to your international provider, that money stays in, and you can use that into building your infrastructure. One of the key things that happens is you start getting a bigger and better. Remember when I mentioned CCTLDs, the country code? So you get bigger country code culture. People start registering in Azerbaijan, for example, .az, because it's cheaper, it's closer, and it's faster than going to, let's say, .com, which would be more expensive, and going out. So all of that are multiplier effects that happen within the country. So you find the content industry growing within the country. More and more people get better experiences, so they upgrade their connections and so on and so forth. The money stays within, so more connections get, and that multiplier effect benefits the country.
Why don't we move on to Jane's slides about internet governance organizations, and then we can come back to questions at the end.
Absolutely, and I'll try and speak slowly so that is it being translated? Okay. So these are some of the acronyms you may have heard throughout the meeting, and as Bill had said, next year we hope to have this closer to the beginning of the meeting. But in any event, you'll know now if you go to a meeting and you hear these things. The Ietf is the Internet Engineering Task Force. It meets in person, meaning physical meetings, 3 times a year. But the work operates continuously through online working groups. If you're interested in IPv6 or routing or anything like this, they're doing work on this continuously, but because it is the organization and the home of internet standards. This grew up almost 20-something years ago, and some of the founders of my organization, the Internet Society, were also some of the key people who helped found the Internet Engineering Task Force. The task force meets to define open protocols. These are the standards that help make the internet run and talk to each other. And this is where the internet companies go, ISPs, IXPs, people like me sometimes will go. I'll interface. Bill's the type of person who might build the standards. It's a really interesting group, and it's bottom up. You don't go as a country. You don't necessarily go as a company. You're a person, and you can participate in any way you want. We actually have fellowships from the Internet Society to fund people to go so they can understand how it works, so you can participate and help build the standards. The IESG is the Internet Engineering Steering Group. It consists of people called area directors. They help direct the work, specific types of work, and they're responsible together for the IETF's day-to-day functioning and productivity, meaning trying to move the work along in an efficient fashion so the standards can be pushed out faster. The IAB is the Internet Architecture Board. It's a body of experts across the various spectrums of Internet technical knowledge who provide the guidance and oversight of the IETF work product. If they help steer things at a certain level too. Operational standards, the network operator groups, each meets 1 to 3 times a year in the local region. There's an African network operators group, the North American network operator group, South Asia network operator group, the Middle East network operator group. I think there's PACNOG, CARIBNOG. What this is, why these are important, why the NOGs are important. There are technical experts at these meetings, training technical experts who learn more by going. There are fellowships throughout the regions for people to attend, whether you're a network operator, a peering coordinator, or other. There are experts, for instance, a colleague of yours, Hisham's, named Nishal, who was working with me at an IXP training. He did the training. I was watching. Also goes to the African network operator group meetings to train, and my colleagues in the Internet Society also go, and someone like Bill would go to help build that capacity throughout the region. They're excellent ways to learn, and there's also just a good ecosystem of people there. And you can go and ask questions and not feel as though you're being embarrassed if you have that question, because everybody's there to help learn. Very important capacity development. Exchange point operations, as Bill's saying, we had talked about the IXPs in the various places. I think we've probably talked enough about it, but Bill's group, some of my colleagues help build best practices within the IXPs. An IXP is a lot of technical infrastructure, but you have to have that human infrastructure around the IXP in order to make it run. The trust element of having people come into the IX and exchange their traffic. It's not just boxes and wires, as a friend of mine likes to say. I'm going to skip to the next slide. User advocacy, the organization I work for, the Internet Society, or ISOC. We consist of local chapters around the world. We have over 90. They're bottom-up internet community organizations that do everything from host border gateway protocol training to IPv6 training, or apply for local grants to help build IXPs. So if you're not part of an ISOC chapter in your region, you can come talk to me later. They're just sprouting up all over the world right now, which is great. Again, ISOC is a bottom-up process, group of people working together. and we represent the end users in the policymaking and regulatory process, also in standards. ONI, the Open Net Initiative, is an independent monitor of censorship and transparency on the internet, protecting end-to-end connectivity. The ICC, there are many people here who are part of the ICC, the International Chamber of Commerce. It's a global advocate for industry and enterprise internet use and policy concerns. So there are lots of different entities around the world that are trying to pull different advocacy elements together. Uniquely assigned identifiers, we identified the IANA earlier, the Internet Assigned Numbers Authority. It's the root of the delegation hierarchy, which maintains uniqueness in domain names, IP addresses, autonomous system numbers. You have to have an autonomous system number if you're an ISP because they talk to each other, and that's how the networks know where to go throughout the system. And protocol identifiers. The IANA's operations are defined by the IAB. I told you about the Internet Architecture Board before, through the Internet Engineering Task Force. Rfc Standard Documents. And RFC is a request for comment. It's actually a standard worked on in the Ietf space and throughout the year online or physically at the Ietf meetings. The IANA delegates specific functions to resource-specific registries that we can explain to you later. That one's a little bit more complicated. ICANN is the Internet Corporation for Assigned Names and Numbers, community-driven organization, and it hosts the IANA function. IP addresses and ASNs. The regional internet registries, Hisham is part of Afrinic. These are the entities that assign addresses to ISPs. IANA gives them the addresses, they push them out to the users. LACNIC is in Latin America and the Caribbean, Afrinic, Africa. RIPE NCC is Europe, Central Asia, Russia, and the Middle East. ARIN is the American Registry for Internet Numbers, and APNIC, Asia Pacific. There are hundreds, if not thousands, of members of most of the RIRs who receive their IP addresses from them. They're important organic bottom-up internet community entities that also have extreme technical expertise in both some of the statistics about the internet, how traffic works, IP addressing, and the uptake and deployment of IPv6. Important to go to some of these meetings because you can learn a lot from the internet practitioners. The NRO, the Number Resource Organization, is the coordination body which allows all of the regional internet registries to act as a global cooperative. And the ASO-AC, part of the ICANN process, the Address Supporting Organization Advisory Council, meets at the ICANN meetings and represents the NRO at ICANN. Next is operational support. The Network Startup Resource Center is a great colleague of actually ISOC's, and I think Bill works very closely with them as well. They provide training materials and resources to people around the world, quite frankly, who are connecting their communities to the internet. We've worked with them closely on CCTLD, IPv6, IXP training, and other. Packet Clearinghouse, this is Bill's organization, provides operational support and services for the critical infrastructure at the core of the internet, from IXPs to domain names and a great partner throughout the world with many of the internet community in building internet exchange points. First, the Forum of Incident Response and Security Teams coordinates internet emergency responders around the world. Some of you may have critical internet resource teams in your countries. It's very important to have certs, and Bill has some firsthand experience with some of the DOS attacks that have happened around the world and where it is important to have a cert in your country. So if you have any questions about how to set that up, come talk to him. And now we are in the discussion mode.
I just want to point out that a lot of the organizations that Jane mentioned have booths outside. Yes. So the NRO has a booth, ISOC has a booth, ICANN has a booth. So go to them and talk to them, see the material that they have, and in the case of the NRO, see the people that from your region, your RIR, to talk to you about the NOGs as well and when the NOGs meetings will be. I just wanted to add that.
And I should say many of us are nonprofit organizations. I know that sounds odd that our main mission is to bring the internet to the world, and it is. And we've done this for years, as well as our colleagues. We have no interest other than seeing the infrastructure grow. People have more capacity built, and we have great connections around the world. So if you have any questions about where you might find training, there's a lot of free training. There are a lot of people you can talk to online. A lot of the network operator groups and all of the RIRs have online chat groups. So if you have a problem and you can't figure out what's going on the network, you can ask a colleague online. So it's a bit anonymous, so you don't feel embarrassed if you're asking the question.
So we've got, 10 more minutes. Bev, do you want to get a mic to the gentleman?
Hello, thank you. Mawaki Chango, Association for Progressive Communications. Your last point actually touches upon the question I wanted to ask. The training, the peer training that's happened among the structures such as AFNOG and their peer structures. How is it funded? Is it I guess they do travel to meet and to do those training, at least some part of it, and how is it funded? So that's the first question. The second question, I would like you not to forget to specify the IANA function that you said you'll come back to later. And the last question, let me try to put it as simple as I can. The internet model, the routing model that you explained earlier, which led to a lot of discussion. What I'm understanding also about it is that since the voice communication is simply a voice, is simply based on voice. The cost may differ based on the distance and the time, but the content is one type of content. While with the internet, there's an incentive to build content. People build content. So that model allows us not to penalize people who build the maximum of content so that they don't have to pay for delivering the content. It's the party that requests content that will need to pay.
No. In the internet model, both sides pay. Each side pays their half.
Okay.
Right? It's not that the person who produces the content has to pay for the whole thing, or that the person who requests the content has to pay for the whole thing.
Okay.
In the internet model, each one pays their half.
All right.
Yeah.
That's right.
So
my question is, when I was listening to that, I just thought of the cell phone model that we have in some parts of the world, where the caller pay and also the receiver pay when they have those plans that you subscribe to, like in the US. The person who initiate the call gets a discounted on their airtime, and the person who received the call, although they haven't asked for the call, also they get to pay on their airtime. Is that normal in this context, or is the customer screwed somewhere in that model?
Well, I mean, the internet model exists, right? You're all used to it. People pay to connect to the internet, and that's sort of all-inclusive, by and large. So you can compare that to other models. Certainly there are cell phone models where you pay a bit and you can send and receive calls. They're just different models, different things. You can, as a thought experiment, you can try and figure out a way of applying one model to a different topology. But nobody's any more expert at that than anybody else. So let me quickly address the question about training and how that gets paid for, and then Jane can take the IANA functions contract question. So the question was, there's all this training that happens at the network operators group meetings. How does that get paid for? There are a lot of different network operator groups, roughly 20 or 25. And there are more that get started periodically and some die out periodically. So they're all, each one is independent. So they're all free to do it however they want. But pretty much universally, the meetings have a small fee to attend to cover, the meeting facility and lunch. And the speakers are required to pay their own costs to get there. So if you look at something like MNOG or an AFNOG, those tend to be heavily dominated by workshops, educational workshops. So there may be as much as 10 days of workshops in advance of a 2-day conference, right? And this is because those are in regions where most of the attendees have very high travel costs. And so they may be spending their entire year's travel budget to get to one meeting. So they try and maximize and get as much as possible out of that one meeting before going home. By contrast, if you go to a NANOG meeting, in North America or a JANOG meeting in Japan, you'll find a very intense 2-day meeting with, conference sessions with, 10-minute, 15-minute, 20-minute, 45-minute talks with people going through slides very, very quickly, and it all gets crammed into a very short amount of time because these are places where travel is cheap, but people's time is very expensive. So there are different models, but pretty much universally the NOGs are inexpensive to attend, and the speakers are not paid to speak. They cover their own costs.
We also fund some of the fellowships for people who would like to go to network operator group meetings. We also have something called the African Peering and Interconnection Forum, where we pay for people to come from different countries because we know that they're running an IXP and they need the assistance. This is 2 to 3 day meetings specifically for peering coordinators, network operators, IXPs, ISPs. You interact with colleagues from around your region. This is specific to Africa, but you also know, if you have such a big continent like Africa, you may not know the person who's the peering coordinator in Mozambique if you're up in Tunisia. So these meetings also help create a central place where people can come together and say, what is your autonomous system number? Okay, you're the person I emailed the other day, and you can see this person where you can trust them just a little bit more to know that you can do business with them. So that's the benefit of different meetings around the world. We help fund that, and we help fund people coming because we know it's the benefit to the internet itself to build up the technical expertise. So, yeah.
So also to add on that, for the RIR's perspective on this, the regional internet registries, so they're membership-based organizations. So they, what they do is they collect membership fees each year, and they use that money to do trainings. So they tour their region doing trainings. They have 2 face-to-face meetings where they do meetings, and they usually do trainings at them as well. So if you attend them, you'll probably get a training as well. So back to the Ayana question.
Okay, we have an online question.
Oh, okay.
We have the IANA question.
Oh.
Could you repeat the Ayana question because I wasn't quite clear what the
No, you
question
just said
was.
that there was something you said about coming back to
Oh,
IANA.
sorry, yeah.
What is the IANA functions contract?
Right, the IANA functions contract. It's a contract, this is tricky for me to... I used to work for the NTIA, which is the National Telecommunications and Information Administration. I did not do the IANA work, so I can answer this question. I did IP addressing, I was much happier doing addressing. So the NTIA has a contract with ICANN to help run the IANA functions. The IANA functions is the root of the delegation hierarchy, which is the A route, which is through a contract also with VeriSign. There's a three-way relationship with respect to changes in the root zone file, which is held at VeriSign. This is something that has been discussed quite heavily, energetically around the world, that contract itself is monopoly control by the U.S. government. I can tell you, as a human being that actually worked at NTIA, don't even think that that's the case, because the work that goes on at NTIA is simply when ICANN sends them a note to say there's going to be a change in the root zone file, and that root zone file, sorry, that's me. The root zone, is there interference? Yeah. Someone might have their BlackBerry close to the system here. That root zone file is changed through a 3-way process. A request comes down from ICANN to the NTIA saying, we have a request, we've done the due diligence, we've talked to the CCTLD in X country, and we know that this is the real person, we want to change the server's IP address. Is that okay? The staff at the NTIA take a look at this and say, you've done your due diligence, go. And it goes back up, it's encrypted. The message is also CC'd to VeriSign. ICANN then sends a message to VeriSign. ICANN says, okay to VeriSign, go ahead, make the change. VeriSign says, fine, we'll make the change. They make the change. That's it.
If you were going to look for a conspiracy theory or delve further into this, so there's the U.S. government, which you can say is providing adult oversight, to keep ICANN from running amok. There's ICANN, which is doing the work. And then there's VeriSign. So, I don't know, you can figure out where to look. Anyway, any other questions?
I will say one thing.
Online question?
Let me elaborate one thing on the IANA functions contract. You've heard about something called the AOC. I'm going to forget what it entirely means, but it's the affirmation of commitment. Sorry, how soon one forgets. The AOC was an attempt by the communities of interest and ICANN and NTIA through comments through a public process to the NTIA to try and internationalize the process with ICANN. And it's a good point that there's an ICANN booth. You can go talk to them. They're a very open organization. They have meetings 3 times a year, I think, physical. You can find all of the information that you're interested in about the organization, about the relationship with NTIA. There is a stewardship role and I don't want to speak for them at all because I used to work for them, but I did not do this work. That's just a disclaimer. But again, there's an attempt to bring more international participation, and that's through the Government Advisory Committee, the GAC. There are over 100 governments participating in that process, and you can definitely find out more at ICANN, through the ICANN booth. There was one thing I was going to say. There was a recent process through a very open, consultative international process to look at the contract between ICANN and the NTIA. Hundreds of people, or at least 90 people, 90 organizations and governments put their inputs into the NTIA to help strengthen that process so it's more international and that there's a more technical stewardship. So if you're interested in more of that, you can ask me offline and we can discuss.
Yes. There is a question. Do you hear me? Yeah, from Daco Gabriel from the ISOC Hub from Cameroon. Very often we hear about Ethernet and Internet, so Mr. Daco would like to know the difference between those two terms. That's all.
Okay, so there's something called the 7-layer protocol model that is used to provide an architectural framework for the protocols, which are like languages that are spoken to move data back and forth. And the internet is a layer 3. The internet depends on a layer 3 protocol, internet protocol, IP. When you hear about TCP IP, TCP is a specific layer 4 protocol running on top of IP at layer 3. But when your laptop gets online using Wi-Fi, that is 802.11 wireless networking. That is a layer 2 protocol. So internet is running on top of Wi-Fi. Ethernet is one of these cables. The cable with cable on the floor, that is Ethernet. There are different kinds of Ethernet, but this is the one that won out over time that uses the sort of phone cables. Wi-Fi is very similar to Ethernet. It's kind of like Ethernet running over the air rather than over copper. So in this protocol model, the bottom layer, layer 1, is the physical layer, and the top layer, layer 7, is the application layer. So the physical layer for that kind of Ethernet, the protocol, is running on top of Ethernet cables that are made out of copper or fiber, or it's running over radio frequency signals, wireless. The wireless or the copper or the light, these are all at layer 1. Ethernet is the layer 2 protocol running on top of that. IP, Internet Protocol, on top of that. Transmission Control Protocol, TCP, on top of that. Things like DNS, the Domain Name System, and HTTP, web traffic, that's up at layer 5. The web server that would serve data would be up at layer 7 because that's an application. So, another question? Yeah.
I'm curious about how governments affect these organizations, and also how this organization affect governments. Like, for example, when in Egypt, when they cut off the internet, how did this organization respond to this?
The Internet Society does, again, we're a nonprofit global organization. We have offices all over the world. We don't have a Middle East office yet. we're exploring whether or not we can, do that. It costs. There's some cost associated with that, and see if that's possible. The Internet Society itself, the staff and the chapters don't. We support the technical, the standards, the policy, and other. We definitely are trying to steer clear of the political, because we don't want to. We could actually jeopardize some of our teams in the regions, quite frankly. We don't want anyone to see us as a political organization, because we're technical, policy, standards, and other. We're advocates for the infrastructure development, human capacity development, technical development. We absolutely can help governments with information about the architecture. To the point where Bill was talking about sending party network pays, we have a paper on that. We've done an analysis recently on the importance of internet exchange points for economic development, and the absolute fact that if you have more internet infrastructure and an IXP, it will bring economic development. We can talk about that later if you'd like. But we look at the technology, the policy, the standards, and try and bring that together to help build that architecture. We'll bring in training if you need it, but we definitely are trying to steer clear of the politics, and that's just something I want to, just throw out there.
I also want to comment on, you probably heard Jane mention more than once, it's a bottom-up organization. And the meaning of bottom-up is that people from the community, everybody in the community has an equal say. So at an RIR perspective, for example, if you have an idea of something to change a policy of how that RIR governs the address pool that it has, for example, or the internet number of resources that it has, you can come, submit it to the mailing list, go to a meeting, and that's how things are. The role that the bottom-up organizations usually play, they advise governments and do some kind of, because they have a lot of technical experience and they've seen a lot of stuff that's happening within the region or from other regions as well. So they usually have like an advisory role to play. Some organizations like ICANN, for example, have something called the GAC, which has governmental representatives that actually have a say on these things. So it depends on the organization, but as Jane mentioned, a lot of them are bottom-up organizations.
And so what that bottom-up model means, the way internet governance works, is everyone gets a say, including governments, right? So every government is perfectly entitled to participate in internet governance just the way anybody else is, the way you are, the way Google is, right? So, for instance, we see a lot of governments sending representatives to internet governance organizations saying, we want to make who is mandatory. We want everyone with a domain name to have to register their contact information publicly so that law enforcement can find them easily, right? Balanced against this, we find a lot of courts and a lot of privacy advocates saying, no, people should be able to be anonymous online if they want to be, right? So here you have two competing interests in government, both exercising their right to speak within the internet governance structure. Looking the other direction, my organization, unlike Jane's, does have a lot of interaction with government. So, for instance, when the cutoff happened in Egypt, we had equipment that was turned off in Ramses Exchange. And so there were a lot of governments that came to us wanting to know what was going on. And so we were talking with people in the Egyptian government to try and figure out what was going on. And we compiled a report that helped other people understand what was happening there. So this kind of thing falls within part of our purview. But many internet governance organizations do make a special effort to help communicate to governments because they understand that governments are sovereign within some area that has a lot of internet users in it, and if a government really misunderstands how the internet works, it will have a negative effect on the internet and a lot of internet users. So in terms of control, governments have no more say than anybody else. But in terms of getting information and training, often governments are, prioritized and take a lot of advantage of that.
I should say that there are many government officials and many emerging economies that are part of our ISOC chapter process. They've created the chapters, they run the chapters, again, bottom up, but that I don't want you to think we exclude. We absolutely, and as Bill's saying, more from a technical perspective, and his organization with advising governments on the technical infrastructure in Egypt, we work with governments across the world on policy-related issues and information if they ask us for it, or connections. So that's something we do absolutely. But I just want to separate the political from the policy. Thank you.
All right. If there are no more questions, if anybody has questions that they, a remote participant. Okay.
Here is a question from Daco Gabriel again ISOC Cameroon Hub. How the traffic generated by users is handled by ISP? Is the traffic generated billable or not? Billable.
Billable.
Yeah.
Right. So if the traffic coming from a user goes to an internet service provider, that means that they're a customer of that internet service provider. So customers pay their provider. That's the transit relationship. It's the ISPs that don't necessarily pay each other, right? There are often not settlements between ISPs, but between an ISP and a customer, yes, that's where the money to operate the system comes from. Any other questions? If not, I'm sure we're all happy to answer questions. Oh, yeah? Okay. Or, yeah, we're happy to answer questions individually. Just come on up. We can shut the session down, but continue informally.